Hello friends and welcome at my channel. Today I'm going to prove formulas for the sine, cosine and for the tangent of a tripled angle. So let's start. Number one, we want to consider sine of 3 alpha. Sine of 3 alpha should be equal to 3 sine of alpha minus 4 sine cubed of alpha. How can we prove this one? Well, you see, we're just considering sine of 3 alpha, and we can write it as sine of 2 alpha plus 1 more alpha. We've done the formula for the sine of the doubled angle, so we're not afraid of having sine of 2 alpha. It's still better than 3 alpha because we're decreasing the complexity. So we are having sine of the first angle times the cosine of the second plus the sine of the second times the cosine of the first. All right. Sine of 2 alpha, it's 2 sine alpha cosine alpha. Now you see we have it squared. Plus, we have sine of alpha. Cosine of 2 alpha is cosine squared of alpha minus sine squared of alpha, if you remember that. All right, so what we can do now, we are, we're better at this point than the previous situation because we're better off because we are having just no tripled or doubled angles anymore. So we are having, as you can see, 2 sine of alpha cosine squared of alpha plus sine of alpha cosine squared of alpha again, and then minus sine cubed of alpha. Right? Does it make sense? Think so? And what we're having now is we are adding, we can take cosine squared of alpha out of the parentheses. We are having 2 sine of alpha. Oh no, we don't even have to do this because this is the same. We just have 3 sine of alpha here, right? So we're still having minus sine cubed here. And well, it's already kind of something like where we want to end up. The only problem we have is with cosine squared of alpha. Well, we can solve it if we just rewrite it as 1 minus sine squared of alpha times 3 sine of alpha minus sine cubed of alpha. So we're multiplying it out. We're having 3 sine of alpha minus 3 sine cubed of alpha and 1 minus 1 more sine cubed of alpha. So this is 3 sine of alpha minus 4 sine cubed of alpha. And that's what I wanted to prove. So number 1 is finished. Number 2, what do we have? Well, we want to do the same for the cosine. Cosine of 3 alpha is equal to 4 cosine cubed of alpha. I have to write it up because I don't remember those formulas, and I must tell you I'm not trying to remember that even, because every time we need formula we can prove it, we can derive it, we don't have to remember or memorize anything. Try to understand the concepts. How do we approach this one? Well, cosine of 3 alpha is once again cosine of 2 alpha plus alpha. This is cosine of the first angle times the cosine of the second minus the sine of the first times the sine of the second. And now we're moving forward. We're having cosine squared of alpha minus sine squared of alpha times the cosine of alpha minus 2 sine alpha cosine alpha, and now 1 more sine alpha is giving us squared. We multiply it out. We're having cosine cubed of alpha minus sine squared of alpha times cosine of alpha minus 2 sine squared of alpha cosine of alpha. So we are having cosine cubed of alpha, minus 3 sine squared of alpha times the cosine of alpha. And now we're doing the same kind of trick. So this is cosine cubed of alpha, minus 3, 1 minus cosine squared of alpha times cosine of alpha. And this is cosine cubed of alpha minus, you see, minus 3 times 1 times cosine is giving us minus 3 cosine of alpha. Minus 3 plus 1 gives us, times minus 1 gives us plus 3 cosine cubed of alpha. And we're basically having cosine 4 times cosine cubed of alpha minus 3 cosine of alpha. That's the start. This is number 2. All right, and let's move to number 3. Number 3 is telling us formula for the tangent of 2 alpha. This is going to be 3 tangent, sorry, not 2, 3 alpha. We're tripling. 3 alpha. This is 3 tangent of alpha minus tangent cubed of alpha divided over 1 minus 3 tangent squared of alpha. Okay, the approach is the same. Tangent of 3 alpha is tangent of 2 alpha plus alpha. This is, if you remember that, fraction tangent of the first angle plus tangent of the second one divided over 1 minus product of tangent of the first times the tangent of the second. Okay, now tangent of 2 alpha, how do we approach this one? Well, this is, as we proved in one of the previous videos, but let's do it one more time. This is tangent of alpha. So you remember, let me just write it down. Tangent of 2 alpha was tangent of the first. Well, let me write it completely. Tangent of alpha plus beta. For you now to remember what I was doing, and for me to remember as well, by the way. So this is tangent of alpha plus tangent of beta divided over 1 minus tangent alpha tangent beta, right? So this is the formula I've been applying here for this case. And now we have alpha and beta equal, and that's why we're having 2 tangent, look at this formula, put for beta alpha, 2 tangent alpha divided over 1 minus tangent squared of alpha plus tangent of alpha still. This is our crazy looking numerator, and the denominator is 1 minus, well, 2 tangent of alpha divided over 1 minus tangent squared of alpha times tangent of alpha multiplied. Okay, now it's only about simplification because we are with tangents only, so we have singular angles, no cubed nor no tripled or doubled angles anymore. So we just bring it to the same denominator. Okay, we have 2 tangent of alpha plus tangent of alpha times 1 minus tangent squared of alpha divided over 1 minus tangent squared of alpha. It was our numerator and denominator, and we are multiplying times the reciprocal of this result. So let's see what we're doing. Well, we're having for sure 1 minus tangent squared of alpha in the numerator. What do we have in the denominator? Well, we have 1 minus tangent squared of alpha, and then we're having minus in here, and we're multiplying them together, so minus 2 tangent squared of alpha. So I'm multiplying it. I can cross cancel those two. It's getting slightly easier. And now you see, if we multiply it out, we have 2 tangent of alpha plus one more tangent of alpha minus tangent cubed of alpha divided over, now only this one is remaining, 1 minus 3 tangent squared of alpha, and you see it's exactly what we want to have. It's 3 tangent alpha minus tangent cube of alpha divided over 1 minus 3 tangent squared of alpha. I don't want you to try to memorize those formulas. As you can see, I'm not doing it myself, so why should I ask you to do that if I'm not considerate of doing it myself? But I think it's nice to see it once, the derivation, just to understand how the mechanics is working behind it. And once you've done it, well, it's clear how to work with 4 alpha, 7 alpha, and so on. All right? Thanks for watching, and see you guys in the next video. Bye-bye, all the best.